Now we'd love to introduce Alex Liu, who is Head of Additive Manufacturing Program of Asia at ASTM, along with all the other panelists.
My name is Alex. I'm from ASTM International, based in Singapore. And today I'm very pleased to be the one moderating this panel discussion. The theme is on additive manufacturing opportunities and trends across APAC region. I'm very happy today with me we have 5 panelists that I see now. Let's go to Wesley first.
I'm from the A-Star SIMTech, Singapore Institute of Manufacturing Technology. I've been working on the AM for almost 9 years, and I specialize in metal printing. We have worked a lot on the applications for industry across different sectors. So I'm really happy to be here today to share some of the insights with you guys.
Thank you, Wesley. Next, we'll go to Zhen.
Hello, everyone. I'm Zhen. I'm actually from SIM Solutions. I'm currently the lead application engineer. So I started my journey in AM since 7 years ago from polymer and plastic printing. And then since 3 years ago, I started to specialize in metal AM. I'm glad to join today, and I hope to share my knowledge and my experience with all of you.
Thank you, Zhen. Very good. Okay, next we have John.
Involved with the additive community for quite a few years, and it's just in Australia now is growing at a fairly great rate. And of course, there's a lot happening now within the additive community across a huge range of happy to talk about that as we go forward, and also talk about how the government also is looking and where it's looking to support in what industries.
Okay, next we have Vaman. Vaman, can you introduce yourself?
Myself, Vaman Kulkarni. So I used to work for Honeywell Aerospace for last 15 years, and I just took a retirement about 6 months back. I was responsible for the mechanical systems and components in Honeywell Aerospace as director. We started our AM journey in India here in 2014. It's about 7 years now. And we have made some great progress in adopting the AM technology in the area of defense aerospace. And I interacted quite a bit with all the AM industries in the country. I'll be more than happy to share my experience in the AM as we go along in this panel discussion.
Thank you, Vaman. Okay, next we have Hiro-san.
Yes, hello everyone in the world, and I'm Hiro Maruoka, and I'm working for Marubeni Information Systems as of Stratasys and Desktop Metal contracted distributor. I'm an application development engineer. Thank you for having me today.
Simon, can you introduce yourself?
So I'm Simon Lee of AM Ventures, who is a dedicated venture capital firm based in Germany to 3D printing topics. So we are very unique. We are only purely investing into 3D printing relevant startups. So I'm in charge of the Asian region. So I'm always looking for good talent and good startup in this Asian region. And I think this initiative is really highly, impressive, because now I was looking for the startup by each different separate regions, but now I think we have a good platform which can be quite benefiting to our activities as well. So
I would like to start off with Wesley first. So Wesley, after hearing the presentation from Dr. Ho, we see that there is a lot of activities revolving AM in Singapore, and also most of the activities are driven by the government. So my first question would be, what are the AM opportunities with regards to specific industries that are not as established as in terms of adoption that you see in Singapore?
I think Singapore has positioned himself as a trading hub for the APAC region, where AM has been one of the key focus in the Singapore's advanced manufacturing roadmap. As such, I think there are many initiatives with R&D and adoption grants to develop and drive AM to companies both locally and international to help them to adopt and integrate AM technologies into their business. So I think in Singapore, there are quite a number of sectors that are really active in AM. And I think Dr. Ho from NAMIC has covered some earlier on, and I will add on to that and give a few more examples. So for instance, we have a joint industry program between the Maritime and Port Authority of Singapore, NAMIC himself, and Singapore Shipping Association. And this joint industry program actually is to drive the adoption of AM for marine parts. And just last year, November, we have a local startup, F Drones, collaborated with Wilhelmsen and ThyssenKrupp to deliver 3D printed spare parts to a vessel with their drones. So for aerospace, we have Collins Aerospace, who have opened their innovation hub for advanced MRO in Singapore. And this is their 4th AM lab. And it's actually the very first center outside of the United States. And of course, there are other AM activities in the healthcare, life sciences, automotive, robotics, tooling, construction, and even defense. Majority of these activities actually started off as an R&D program, which was greatly supported by the government agency. So I would say Singapore has built a very comprehensive ecosystem to support on the AM activities, which covered quite a large spectrum from material research to component designs to parts printing with really a wide range of AM technologies, all the way to post-processing. And together with the effort from the local Institute of Higher Learnings and Research Institute, we have grown quite a large group of AM engineers and scientists to serve the AM industry as well. So just now I have mentioned about the automotive. Just last year, October, Hyundai actually invested 400 million to build an innovation center for future mobility study in Singapore. And they are actually looking into manufacturing of customizable electrical vehicles. And this is again another opportunity for AM in the automotive industry as well. It could be 3D printing of car components or sensors or even batteries. But of so many industries that we have seen for years, you might actually realize that there are actually very few people talking about semiconductor. And in this case, I'm actually talking about semiconductor capital equipment market. The increasing adoption of these smart electronic devices is actually boosting the manufacturing prospect. And the significance of incorporation of these electronics in automotive application is actually one of the key drivers that is propelling the growth of the semicon equipment market. The integration of IoT, Internet of Things, artificial intelligence, and connected device across various end-use verticals is expected to boost the semicon equipment market growth. And just in APAC alone, the semicon equipment market is actually accounted for $46 billion in 2018, and is expected to grow to $79 billion in 2027. So by just looking at the tech stock today, if you see, you can actually see the semicon space is booming, and this will at least last for another few years. So for those who are from the semicon industry, we know this thing that we call the Moore's Law. And this Moore's Law is actually driving chips design to a level that we cannot imagine. So likewise, I think the capital equipment will also require the constant innovation to keep up with the technological advancement. So I think AM in this case will be very critical to enable advanced materials and complex design, or designs that we couldn't imagine before, so that we can overcome all these challenges in the semicon equipment market.
Thanks, Wesley. I have some AMD stocks, so that's good to know. Having supported the Chinese market for many years, what are some of the trends that you have observed in China over the years for additive manufacturing?
So I think to give a quick overview regarding opportunities in APAC, especially the China region, I think actually in the past 3 years, based on all the research data, it's actually showing that the AM market in China is growing very fast. So from 2018, it started with around 10 billion renminbi, and from 2019, it grows to 14 million renminbi, and all the way to 20 million, which is last year. So you can see as in the past 3 years, the China AM market is growing at a rate of 30 to 40% annually, and it is expected, even given the COVID, the annual AM market can reach 25 billion renminbi this year. So you can see it's a very steady and constant growth in the China region together as a whole APAC region. So I think my next point will be, so if you ask him what's the opportunities, I think based on so many years of development and experience of the APAC experience, also the China, I think there are 3 techniques become very popular in China. So starting from the metal, so which will be SRM, or also known as DMLS, or all the other terminologies, but basically it's the powder bed fusion with metal to produce metal parts for various industries such as aerospace and medical. The second will be the resin-based, such as DLP, digital light processing, where many like in the middle level of the applications, they can produce mass production in fast speed. And of course, lastly, the SDM, the normal desktop 3D printer, producing plastic part. So this three technology from SRM, DLP, and SDM are actually rapidly increasing the market share in China since the past 3 to 5 years. And I will say in the future, there will definitely be more competitors or more market players utilizing these technologies in China or in APAC for more applications and end users. And I think my next topic I want to share will be regarding the applications or R&D development, what's happening in APAC or China. So I will say right now, right, based on research, nearly half, around 48% of the new R&D fall into application, which means how they utilize existing application method to develop actual product. So around half R&D are fall in this category. And another 30%, surprisingly in China, they are focused on equipment, which means the printers or all the hardware necessary to AM. So you can see there's a strong growth that most of the players in this region are developing their own hardware. And the last big portion, around 18%, nearly 20%, will be about the new materials, or the materials which can suitable for the industry need. So as you can see, actually, right, in APAC region, especially China, applications, machines, and the materials become the focus of the whole AM market. And I think these three big categories are the current, like, still maybe considered as blue sea, but maybe become red sea very soon. But I think there is one trend that, as you can see, actually software is very important. But I think based on current market research, software only occupies 0.4% in Asia. And I think right now, most of the users or companies in Asia, we are all using maybe software from Europe or US. And I think, yeah, potentially software can be a really new market for beginners or for startup or for companies to really have a share in the Asia market. Because you know, software design in Europe or US may still have some cultural fit with Asian people using the software. So I would say this is regarding the landscape. I think to move on, if we're looking at the industry, given the APAC region like Asia, I will say, of course, together with both US and Europe, aerospace, automobile, medical, I think these three industries are still also growing because every country, especially for big nations, they have huge demand in this country, in these applications, aerospace, medical, and automobile. But I think in Asia, particularly in China or even Singapore, we actually found out tooling become very popular, or I would say even globally, tooling and the molding. I would say Asians are really good at this. And that's why there are many users, either our customers or even many companies who already engage in AM, they're developing all the new tooling method based on the strengths of AM. Either from metal printing or polymer printing, they try to print the insert or mold, or even introduce hybrid printing. For example, after SRM, you'll get a metal printed part, you're following by the machining, or you print the SRM onto a machine part to get the final molding. So all of this trend, we seldom see outside Asia, but I see within Asia, in both China or Singapore, or even Japan and Korea, you can see there are lots of companies trying to innovate. And I will say this is one of the trends we can observe. I think lastly, regarding the AM opportunity in APAC, I think there is something special regarding three areas. So first one is actually finance. I think as we shared just now, for example, in Singapore, lots of government support, and also in China, at national or regional or even individual level, there are many rounds of potential fundings for companies or for startups to engage in AM. And also at maybe companies or city government, they also provide subsidies and policies for high-tech products and the startup. And I think the second point will be talents. I think in Asia, talents become very important. And I think, yeah, together, similar as Singapore and Asia, you can easily get well-educated masters or even PhDs for researchers and engineers to work on new projects or new products. And I think particularly in China, what make it better is you can even have enough abundant skilled technicians or operators to ensure all the production chains and to ensure you can run your production job 24/7 weekly basis. And I think lastly, the people here in Asia, they are more towards urban mindset. They are willing to try, especially for Chinese people. They really, the moment they have a new technology, they are very glad or open to embrace it. They want to try and they want to make improvement. And I think my last point will be regarding the infrastructure. So I think within Asia, particularly maybe China, there will be very well-established infrastructures from office to roads to power supply, and also lots of good supporting services. Like you can easily find heat treatment, surface finish, or post-process to make your whole AM product or your trial fast and convenient. Especially like in the region of like Guangdong or to the south or to the east, they are really very developed. So I would say, given all of this background, it actually makes lots of opportunities available in Asia with the financial support, with the talented manpower, and also the good infrastructures to support a new AM initiative. And yeah, so I think this will be some of the experience and the observations from my side, and I'm much glad to share with everyone here. Yeah, thank you, Alex.
Thank you, Luton. I think the rate of market growth that you mentioned is really fantastic. And the Chinese market is huge, as we all know. And also, I think we heard that the Chinese government also announced a tax-free kind of initiative for 3D printing, 3D printed parts related to import in order to make the equipment produced in China to be more competitive. So I think in terms of AM market in China is very vibrant, and we are all excited to see what's going to happen in the next few years. Thank you, Luton. John, the question here is that Australia is considered one of the pioneers in AM adoption that you mentioned. In fact, 30 years ago, you brought in the first industrial grade equipment into Australia, and there are several startups working on metal AM technologies. In fact, they are also being sold internationally currently. So what are some of the key industries in Australia that are utilizing AM technologies?
Well, as you know, at the moment, heavily in Australia is being very promoted around the defence. So with your likes of Rheinmetall, BAE, Boeing and the rest. So there is a heavy focus in the defence area. The government actually has brought in $1.5 billion to be put into the manufacturing industry. The 6 focus areas are the major areas, of course, are medical products, food and beverage, resource technology and critical materials processing, recycling, clean energy, defence, as I mentioned, and of course, space. They're the major areas where governments and state governments here are focusing in on. As I think I indicated in my talk earlier, that we have just had such a range of industries that have, and a lot of it is startups too, initially get involved with Additive with this grant system that we gave. That has been absolutely fantastic. And as I said, it's generated over $23 million to date from a $1.3 million investment. So excellent returns. And the government, we're now talking with government to start some other grants up around that. I was very interested to hear on the Korean government with their investment too. That's just wonderful in the AM area. So again, as I said, heavily around the defence area. We're looking heavily at certifications and trying to getting materials certified is one of the big things. There's a lot of research going on with several of our universities around research and into getting metals certified around the defence. RURAG at this point in Australia is probably one of the major ones in the defence area, and of course they're using the EBM and wire arc as well with their processes. We've got the likes, I think I didn't mention Titomic, that's another large company here, which is quite active, of course, in with the new technology. So yes, I mean, the areas that have taken up into production, of course, orthopedics, the areas there. There's 3 companies now in Australia physically manufacturing the orthopedics. They're using the HP technology. That's the main one that they're using. They're even exporting. So that's one area. The other one is medical, and of course we've got a company here in Melbourne called Anatomics. They're doing a lot of the skull, the vertebrae, the joints, and that. And I was very interested. I think it was in 2019. I can't remember the person's name, but she was from China giving a presentation at RMIT around materials and that. And they indicated they were now doing 200,000 implants per year over there. Wow. So the Chinese market is super huge compared to what we have here in Australia and New Zealand. But again, as I said, there's so many range of industries, and industries are slowly learning about additive. And I think I mentioned earlier, one of the major hurdles is they don't know enough about it. They know a little bit, but not enough to look at how it could be justifiable within their own manufacturing processes, how it could operate within their own manufacturing processes. So again, another one, big area here is
John, you're on mute.
Why that happened? Yeah, I don't know what happened there. I thought it must have been you, Alex. But yes, dental is another big area here that's been heavily focused around additive as well. So the main areas, of course, is now heavily in defence. Automotive are using it in the aftermarket. Defence, of course, very heavily. I mean, we've worked in several areas. Mining has taken it up and utilising it in the mining. And of course, this is parts to be made on site. And as we know, Speed 3D have their systems now in the Army at front line. They have it on a naval ship now, building parts as well.
We are all very excited to see what's going to happen with the Modern Manufacturing Initiative by the Australian government.
There's the other one too, through the AMGC, which is the largest organisation in Australia around manufacturing, which is the Australian Manufacturing Growth Centre. Also the DMTC, which is around the defence area, and the IMCRC as well is another big area.
Okay, that's great. Sounds very exciting. Thanks, John. Okay, and next we have Vaman. We are all very excited to hear from you what India has been doing on additive, specifically with your background and experience in your previous industry years. So, India has been utilizing AM way back in 2000s, and they have a huge focus on tooling as well, as we understand. So how has this trend evolved over the years? And also, we know that the Indian government recently announced a national strategy for AM. And where are some of the opportunities that you see for AM in the next 5 to 10 years?
Sure. Thanks, Alex. Let me share my perspective on the questions what you asked. Yeah, definitely India started leveraging 3D printing or additive manufacturing almost more than 20 years back. It was mostly in the area of prototype and tools. And those days it was more towards leveraging the plastic or the polymer parts so that we can have a quick design visualization or the customer demos or the assembly checks, or even some small functional tests could be done to verify and validate the performance of those components and the parts. But it has changed a lot once the metal additive manufacturing has come into the picture. And the growth has been really very fast in the last 6-7 years, I will say. 2014, when Honeywell started establishing a AM center in India, there are only some 3 or 4 players who used to be there. And most of them were in the very initial stages, and everybody was in the initial learning curve, and whether it is related to the what is the best way to support the part, or what is the best way to print that part. And the success rate used to be less than 50% when the industry started in that situation. But in the last 5 years, I will say the application of AM, basically I will divide this into 3 parts. The first one is the Indian industries. The Indian industries, again, there are two types of industries. One is the public sector or the government-funded industries, and the other one is the private industries. Most of the government-funded industries is in the area of aerospace, defense, and space. So they still continue to use it for the prototypes, but the prototypes is more completely a functional part today. And the decision whether they use this for the production version is kept as an open decision, and then they make that decision. There are quite a few examples. One of the recent thing is the Hindustan Aeronautics Limited have been developing a turbofan engine, and there are multiple parts, whether it is the compressor stator, or it is the turbine casing, or the combustion chamber. So those are the things which additive is being very, very extensively used, and then to completely go ahead and then do the testing. One of the challenge the aerospace and defense faces is the certification and the qualification challenges. So in that area, I see that yes, we are in the initial stages to get the approval from the required approval agencies, but we are leveraging a lot from what FAA is doing in that area, so that learning could be quickly adopted from the certification and qualification point of view. The second industry, which is the Indian local industries, typically it is more in the area of automobiles, medicine, healthcare, and a lot of other process industries, the oil and gas. So that is where the big application is happening in the area of additive. The education skills which have been developed, it's need to be more streamlined, I'll say, especially because when you start looking at the additive benefits, if you just replace an existing part with an additive, you don't get the other benefits what additive provides. Typically, like additive can definitely improve the performance, leveraging the whether it is a lattice structure designs, or it could be topology optimization in terms of reducing the weight. So those typically, to get those benefits which AM offers, the skill is being developed today, going through a very streamlined approach of design for additive manufacturing. But industry is definitely adopting, especially the healthcare. I think just John mentioned about the dental applications or the implants which are happening. India is identified as one of the low-cost medical services what India can provide, and providing this additional leveraging the additive as for the implants is definitely going to add additional benefits. The third thing which I wanted to talk about is the number of MNCs, multinational companies, which are here in India. Almost every big OEM has their setup here in India, but they initially started as the engineering design centers. Less of manufacturing activities, but more of lot of design activities. And now with the additive coming in, and I just mentioned about the design for additive manufacturing, which is playing a big role. Any product design has to look at additive as the first option today, because because of the benefits what additive provides. So all the design centers here, their approach has changed, so that they will look at additive as the option to either to get the best performance or to have a lesser weight parts, or it could be a cost-driven decisions which is making. So the design community has really started looking at design as definitely an option. And many of the MNCs now started setting up either their own manufacturing centers or leverage the supply chain which is there in the country. And that's where the additive manufacturing service centers which have come up. I will say that there are more than about 50 to 70 additive manufacturing service providers who are there in the country, and they have invested a lot and they're ready to invest further to leverage this additive manufacturing. And that scenario will definitely change. A COVID situation has slowed down this process in the last 1.5 years, but I think that is a passing phase, and then we will come back, and then the leveraging additive is going to be the big phase. You talked about a specific question about the national strategy on the additive manufacturing. Yeah, there is a very focused strategy on additive manufacturing. This is as part of the Made in India approach, or we call it as the Atmanirbhar Bharat, where we wanted to be more self-independent and then reduce our dependency on the imports, what is happening. So there is a lot of government initiatives to fund for all the innovation and research activities. I think in the earlier Aditya mentioned about Indian Institute of Technologies and the Indian Institute of Science and then other education institutions. Apart from providing the necessary skills to have a trained manpower for the industry, a lot of basic research and development is also happening. It could be in the area of metallurgy, because especially when you talk about the sintering process, the microstructure related activities, and how that can be further improved and then optimized, or in terms of developing the new materials. In fact, in the last 4 to 5 months, there is an industry which developed a complete process parameters to build the parts out of copper, which is going to completely change its applications for the electronics industry as well as for the heat exchangers and other areas. So a lot of research activities are also happening in those areas, and which government is definitely supporting, encouraging, and a lot of funding is provided to these education institutions to encourage the basic R&D activities. Overall, I will say that whether it is aerospace or defense, or it is automotive or healthcare, or even the MNCs leveraging the India supply chain for all the global markets situations, it has been it's been very, very encouraging, and that will be growing in the next couple of years, Alex. So that's my thought process here.
Oh, thank you, Vaman. Very insightful. Next to Hiro-san. So Hiro, just now we hear the presentation about Japan, and we know that Japan has fundamentally been really very strong in equipment manufacturing, and there is also this Technology Research Association for Future AM in Japan that was almost close to $40 million US, a national project to drive development of metal AM systems. So how has this helped the local economy and industries as a result of this program? And also, what are some of the ups and downs in Japan that you have seen over the years in terms of collaborating with other industries?
Yes. First of all, just give me a second for my message to Japanese audience. Just a few seconds. 日本からご参加の皆様、誠にありがとうございます。マルベン情報システムズ丸岡です。もしコメントとか質問とかあったらチャットとか、あとこの後のネットワーキングのテーブルで、お伝えいただければと思います。Thank you for your waiting. And so let's get started for my turn. And first of all, the Japan market might be mysterious or invisible for everyone, but even to me. And however, but there are a lot of reasons that, for example, thanks to the comments from Peter Rogers in the chat, and Japan has some characters, and also we have some difficulties, for example, language, and also culture or something. But But basically, we have used AM correctly by some early adapters in particularly in prototyping area, not only for automotive but also many very varied industries. And Japan might be the earliest adapters, one of earliest adapters of AM in 1990. And also, on the other hand, we have difficulties to utilize the AM technology more. For example, we don't have huge defense industries or aircraft industries and so on. But I'm still optimistic about the growth in Japan, because even, for example, even for plastic injection molding, it took 2 or 3 decades to be adapted for in general and in broad, but the it takes time and step by step. But also the issue is or challenges is not the technology of 3D printers, but the most important thing is people, and people should be motivated or well by right information and knowledge and about AM, because AM should not be used for partial kaizen or just a cost reduction, but AM should be used to renovate or innovate supply chain or engineering chain and economy chain as well. Therefore, Japan has potential to use AM more for stepping innovation, for example, digital transformation as well. And also, Japan has market a certain amount of market about robotics and also gaming and toy industry, and they have quite a lot of potential to utilize the AM technology more. Therefore, we have some challenges, but I just put the message to you about, and APAC people will play an important role to develop not only 3D printers hardware, but also material and software. Software is quite my top priority is software and data and the post process. These 3 areas we have a lot of potential to play an important role, not only for domestic industry or economy, but also in worldwide. That's my perspective and the message to you. Thank you.
Thank you, Hiro, for the very good inputs. And going on to Simon, last but not least, also one of the most interesting ones would be to hear from him about the startup scene, not just in South Korea, but also in Asia. So Simon, would you like to share about how do you see the AM startup scene in the APAC region?
Okay, let's talk about general AM players in the market first. So we see roughly sorted it out. In Asia, there's only 10% of AM players located here, and there are about 60% of AM players are located in Europe and 30% in USA. And at the country level, there are like 30% based in Germany and 30% in US. So they are kind of top level countries who is producing a lot of companies or startups. And traditionally there were like a few of companies like since from 1980 to 2010 who actually invented and commercialized kind of key AM processes in the market, who's still generating a lot of significant revenue and like heavy market share in the current AM industry, like Stratasys or 3D Systems or EOS, actually who are kind of talking about like a FDM process, extrusion process, or photo curing process, and also laser-based PPAP process, right? And we saw a number of players who are inventing new process or kind of complementary solution to the existing AM processes. And we saw a lot of players in other regions, but still not in AM, quite many. So I was asking to myself, why there are not so many AM players based here? Maybe I can assume number of regions. Why? Because there are still lack of AM ecosystem maturity level here in Asia. So what I can say is, since there are a number of key players who already started their AM business like 20, 30 years ago in their own region, it was helping the market to produce a lot of good talent. So they have kind of some time to produce good talent, good ecosystem, so that now they are knowing about what AM is and they know how to apply this technology for. So it is kind of good environment to start up, right? Because they can easily find a partnership there. They can easily find a customer as a pilot customer, and then they can finally go beyond their local market. But in Asia, still we are having lack of understanding first, and lack of like a big players who want to adopt AM at this stage. They want to still study more and more. So as a small company, when they are having great technology, still they are struggling to find a pilot customer, and then still we all know that single AM technology cannot solve every problem. Still, we need to collaborate with other like stages to provide a kind of consolidated like offering, right, to the customer. So we still need partners, but still very hard to find the local based partners. So kind of limitations still affect here, I think. So what I can do is like using kind of this platform. Still, we are having a kind of great platform AM platform in Asia now. So we are needing to sharing more and collaborate, find more collaboration, and then maybe we can make many good success. And maybe one more thing I want to point out is about kind of general difficulties as a tech startup. So if I think AM startup as a tech startup, there are usually three key difficulties for them. So first one is about the lack of market application. Even though they have a great technology, still if there's no one to purchase their solution, it is big trouble, right? And second problem could be a long development time. Still they have a great talent and great invention, still you need to take some time for commercialization. And third difficulties can be technological uncertainty. Again, so even though they have a core technology, still they need to find someone else to help them to develop as a like complementary solution to the market. So what they need is usually about the global connectivity, and also they need a capital for endurance. So they need to still spend some time just burning money. So that's why we are here as a venture capital to support them. And also they need a great network, industry network with the domain knowledge. So that's also what can support. And also I believe there are two different talents actually needed. Basically, mainly I can simplify the two different way of talents in the market. So one is about AM expertise for sure, but it is not really existing in the current level APAC yet. But in the other hand, we have a great expertise in the traditional manufacturing. So our strong manufacturing background and also highly educated people in this APAC region can actually do a lot of good things, I think. Once AM need to be integrated part of the manufacturing, still we need a lot of support from the conventional manufacturing techniques. That's why I think I'm quite convinced about the next movement from the APAC region for the AM startup.
Well, thank you, Simon, for sharing with us these insights. I think it got us thinking the difficulties that startups face, and it is really good that we have companies like AM Ventures to support their journey in their technology development phase. So I actually prepared some questions, but because I wanted to engage the audience more, and also because of time, let us now go to the Q&A portion, where we have this question that is really important, and it has the highest vote. So the cost of metal AM machines are still very high at the moment, as we all know. So how do you see that as a bottleneck and a potential trend? So anyone wants to take up this question?
Maybe it's a scale, economy of scale, I think. Still, the market is too small. So once the market maturity is, maybe when the market is already grown, then maybe we can expect lower cost after.
Yeah.
You know, around the cost with metal, and that metal machines have certainly moved forward and becoming faster as we move forward. Again, we're noting machines with more lasers and that in them now, becoming a lot quicker. It's down now to the powders or to the materials that are being used. They're a high expense. But the other thing too is around design for additive, and looking at taking assemblies and reducing the amount of parts in assemblies and making them as a single part. That is where the justification starts to come in for utilizing metal additive. And again, it's also the build space and how you actually position all the parts for the builds within the equipment. So it's all the skill levels coming down around generative design and around how you're going to put them into the build areas for a fast build, and also how you can reduce the amount of supports on the product. So reducing the amount of post-processing you're going to have on the end products that are coming out of the equipment. That's only part of it though.
If we look at a good high-end 5-axis CNC machining center, the depreciation is about $75 per hour. And comparing that to metal AM printers, it's about $30 to $60 depending on which model you get. So I think the depreciation is comparable, but the production rate is different. You know, which is why a lot of manufacturers now are going towards more lasers to improve the productivity.
Yeah.
Okay, let's go on to the next question. We have an interesting one which I would like to answer. So how does AM contribute to Industry 4.0 and smart manufacturing globally? So I think this is a very interesting question. At least for me, I believe that the development of the advancement of AM really depends on the convergence of adjacent emerging technologies that are under Industry 4.0. That convergence, or if you like, integration of different emerging technologies is essentially smart manufacturing or advanced manufacturing. So this is something where we also see that additive manufacturing is the cornerstone for advanced manufacturing, which means that whenever you hear people talk about smart manufacturing, advanced manufacturing, or digital manufacturing, they always link it back to additive.
I just want to mention one point that regarding the Industry 4.0, because I see based on our APAC experience that in Singapore itself, or in Malaysia, or in China, or even in Korea, we see an increasing trend of combining robotics and AM together. So that's the concept of the smart factory, where because if without robotics, we still need the operators to operating the AM machines. But I think for the Industry 4.0 and the smart manufacturing globally, the trend will be utilizing both robotics and AM. And I think literally in the future, when you want to produce anything, you even don't need operators on site. So everything automated, from printing for post-process and all the part handling. So I will say AM become one of the necessary part in terms of the fabrication part, but working together with IoT and robotics, this can also boost the productivity and the saving manpower and the boost efficiency.
I mean, it depends on how we define smart manufacturing, right? So in this case, Industry 4.0, yes, some people will, will be talking about, machine talking to machines, and everything is digitalized. And in AM, definitely you're talking about digital manufacturing, right? So in this aspect, I think it depends on how you look at it. But to me, smart manufacturing means sustainability, be a responsible manufacturer. And with all this IoT and big data all in place, definitely you have a lot more data to tell you, how we are going to cut the material waste. And even with a 3D CAD model, you have a lot of data to play with, as compared to a 2D model, even AutoCAD kind of a 2D drawing. So I think in this place, AM play a very important role to help out, to shape our future advanced manufacturing.
Yeah, just wanted to add here on the industry 4.0 and how additive is going to leverage that, and then how it becomes part of the smart manufacturing. The simulation and analysis is all part of the cloud computing, which is also part of the industry 4.0, and that additive is leveraging a lot to improve on the quality of the parts what we can do it. So that definitely is part of the design for additive to come out with a better designs. The other one is that you look at the complete supply chain activities and how that can be completely automated. Now that with additive manufacturing, everything is digital, and the localized manufacturing to leverage the low-cost manufacturing which used to happen in India or China, that is not a factor which is going to decide now. So it's going to be the place where the infrastructure is available and it can be printed. And that way, I think we are going to get the parts leveraging the global supply chain in a much faster, and which will meet the quality of the product what we are looking at. The entire supply chain is definitely going to be automated in a much better way with AM.
Thank you, Vaman. I think this is a very nice sharing from you. I have been told that we have overrun the time that is being allocated to us. And on the top left corner, you would also see that this is going to end in like 42 minutes. And we also have a lot of requests that they would like to move on to the networking session. So let's bring Janet back and show us the way. Oh, by the way, it is 5:45 a.m. for Janet. Huh? So
thank you everyone for joining today. We had over 300 people that actually joined throughout the event who want to learn about the Asia Pacific market. And it's thanks to folks like Wataru, Alex, John, Simon, Aditya, who had to just run off just now, coming together to bring this together. And this is a grassroots initiative, and we want to make it possible for everyone to have a voice. So if you're interested in contributing, sharing your knowledge, your know-how, offering your insights even through our complimentary virtual tables, feel free to reach out to any of these country leaders, and we'd be happy to make this platform available for you. Any last words, Alex, John, Simon, Charo?
Yeah, I hope that we can make this event a physical one soon in the future, bringing this event locally to each country in Asia. I think that will bring a lot of benefits to the AM community.
Yeah. I think we need to keep this going. We've started a momentum now, Janet and Alex. We need to keep this moving forward. This sharing can do nothing but good.
From my side, so now is a very interesting time to see a lot of consolidation happening in this AM industry. And I also think not only for the consolidation, but also about collaboration is gaining more and more importance, right? So now we are having a great initiative here, platform to share more. So sharing, and then maybe we can find a good collaboration and also fruitful output in the end.
We hope that we can meet you in person very soon. But in the meantime, we hope that this virtual platform allows you to collaborate and share knowledge. Well, without further ado, looking forward to see you guys all on the virtual floor. Thank you.
Okay, see you guys at the virtual floor.